Hello, this is Faye from Scholars of Calgary Northwest. Today we're going to talk about quadratic functions. A quadratic function is a parabola that either goes up or goes down, and it depends on so many factors that we're going to talk about in the upcoming parts. But here, this is y equals to, yes, x squared, exactly. That point here is called vertex. Vertex is where your parabola changes sides, like goes down, gets to the vertex, goes up, or goes up, gets to the vertex, and then goes down. And that x equals to 0, the y-axis, where x equals to 0, is called the axis of symmetry. Each parabola, each quadratic function, they have different axes of symmetry. Okay, let's do some function transformation. How should we do it? We know that the black graph, the first one that says x squared, is just the simple black one that we drew, we sketched, we graphed, whatever you call it. It's easy. It just says y equals to x squared. You just have to give x values, -1, 1, 0, just to see the behavior of your function, and then sketch it. And you know, since it says x squared, it's going to be a parabola. It's going to have a curve. Don't forget that. Look at the last thing that I wrote here. What is that? It says a times x minus b squared plus q. What does that mean? It is the vertex format of writing quadratic functions. Which one is the vertex? P and Q is exactly your vertex. Let's go to the second one, the one that is in red. It says 2 times x minus 3 squared minus 1. So the vertex is P itself, which is 3, and Q itself, which is -1. So that's our vertex. What is the first number that you see there? 2. 2 is our A. The sign of 2 being positive or negative shows that if my parabola should go up or down. So don't forget that. Since it's positive 2, it just goes up. What does the value of A tells us? If the value of A is greater than 1, and also positive, we're just talking about positive a's here, you can just expand this to the negatives, and it's just same thing, easy. Okay, for the red one, since our a is greater than 1, what's happening to our function? What's happening to our graph? Our graph is going to be narrower. You can see the difference between the arms of the black one and arms of the red one. Black one has something like this, but red one gets narrower. But let's look at the blue one. Yeah, blue one has different P and Q, different vertex, but we're just talking about the value of A. A is 1 over 2, or half. What happens here is that my function gets wider. This is my y equals to x squared. This becomes my y equals to 1 over 2 x squared, or any other transformation. One more thing, whatever that happens to x, whatever transformation you have to write it in the opposite sign. Look at the black one. Black one is at 0 and 0, right? The vertex is at 0 and 0. Look what's happening to the red one. Red one is going to the right, but 3 steps. How did we write it? We wrote x minus 3. Everything that's happening to your x, you have to write it down in the opposite. For the blue one, blue is going 2 steps to the left, but we write it with positive p plus 2. Don't forget these points. These are very important. Okay, we talked about the vertex format. Now it's time for this. A x squared plus bx plus c. What is that one called? The standard form. Exactly. Okay, a is still the same. Everything that we talked about a in the previous video holds here. If a is negative, goes downward. If a is positive, goes upward. If a is bigger than 1, gets narrower. If a is between 0 and 1, let's not say less than 1, because less than 1 also contains all those negative numbers. Let's just forget about negatives right now. We're just talking about positive a's. So if a is between 0 and 1, which basically means a decimal less than 1, it gets wider. Don't forget that. What does the b and c show here? C is the y-intercept. When you have the standard form, you don't need to worry about your y-intercept, where your function crosses the y-axis. It's just your c. Easy. What about the vertex though? How can you find out the vertex? Think about it. You have two options. You can either put this in the vertex format, which is called completing the square, and we will talk about that later, and do it that way and then find the vertex. You can either graph it, find the vertex, or there's another way. In the standard form, when you want to find the x coordinate of your vertex, you can just calculate negative b over 2a. Negative b over 2a. That's the x coordinate of your vertex. Then for finding out the y coordinate of your vertex, just put the x coordinate in there and calculate y. In this case, your negative b over 2a is going to be negative 3 over 4, which is negative 3/4 or negative 0.75. And then instead of x, you can insert negative 0.75 and then calculate for your y. But there's an easiest way. You all own graphing calculators, I'm pretty sure. So you can just graph it and look for the vertex. That's easy. So in this form, what is the axis of symmetry? Exactly the x coordinate of your vertex, so exactly negative b over 2a. Easy again. What are the x-intercepts? X-intercepts are those points where your function, when your graph passes through the x-axis, or basically the zeros of your function. So for finding out your x-intercept, you just have to equate this with 0 and solve it. How? We'll talk about that. Let's just summarize the forms of quadratic function. We have standard form, factored form, and vertex form. For the vertex form, I'm pretty sure your teacher shows it with a times x minus p squared plus q, where p and q is the vertex. Don't forget that. And for the factored form, those r1 and r2 are the roots, or the zeros, or the x-intercepts. Okay, so now we learned everything about quadratic functions. Where are we going to use them? In two different scenarios, but the subject, like the whole concept, is the same, but you might have thousands of different questions in each of them. The first one says projectile motion, height versus time of an object. It's just related to physics. Why? Because movement is a function of time, but based on time squared, not just time itself, or it's not a really linear relation. Maximizing or minimizing values, profit, area, or so many things. Why? Because a quadratic function, if it goes upward, it has a minimum. It starts coming down, down, down until it gets to the minimum, and then it starts to rise again. Or maximizing the profit, for example. Why? Because if you have a function that goes downward, you start to go up, up, up until you get to the max, and then you come down again. Don't forget these areas. These are very important, and you can master them by just solving so many questions and examples. Practice. Okay, this is the last part, so the only thing that you have to work on right now is converting between two different forms of quadratic function. So if you have the factored form or vertex form, it's so easy to convert it to the standard form. You just have to expand power of 2 and then multiply everything and just do the math. But going from the standard form to vertex form is kind of different because it's called completing square, which we will cover later. Just practice. Your exam is so important. Practice and you'll do good.